Good afternoon, everyone. Welcome to this live catch-up with Professor Avi Loeb from Harvard. We're going to be talking about latest news, latest gyrations in the kind of narrative surrounding interstellar object 3I Atlas. So without further ado, I'm going to bring Avi into the room. Hi, Avi.
Hi, good to see you, Mark.
How are you doing with the tidal wave of attention you're getting?
I still wash the dishes at home. In fact, our dishwasher just broke down. I ordered a new one by calling the company, and as soon as I started speaking, the person on the other side I've never met said, "Is this Avi Loeb?" And I said, "Yes, it is." And he said, "I recognize your voice from all the podcasts and interviews on television that you're making, and it's a great honor." What is the status of 3I Atlas? He asked me. Now, I just called to order a dishwasher, not to this, but I gave him the upshot. But it shows how widely spread, everyone is talking about it.
More and more people are. I mean, certainly, my children's friends are beginning to ask a little bit more. They're saying, "Oh, you're talking to Professor Avi Loeb again, are you? Can you tell us this? Can you tell us that?" When we were last with you, we were very much at the point where 3I Atlas had kind of come round the back, or was coming around the back of the sun. It was a bright blue. There was the suggestion of artificial acceleration, perhaps sideways and directly onwards. And then that's really where we left the story. We were at that sort of perplexing stage where I think I'd suggested to you, were we looking at, if it hasn't fallen apart when it appears, is this the next anomaly in a sense? So let's pick up the story. What's happened since?
Yes, so on October 29th, 2025, the 3I Atlas came closest to the sun, and it received 770 watts per square meter. And the question is, did that stress test affect its nature? And what we learned around that time is that it developed a non-gravitational acceleration. It was reported at a level that implies that it lost 15% of its mass just to get the boost. If it's a natural object, we know the characteristic velocity by which volatiles that get sublimated flow out of the surface of a comet, and that tells us which fraction of the mass needs to be evaporated to explain the non-gravitational acceleration, and it's 15%, a very large chunk. And if that's true, if it is indeed the natural comet and the acceleration derives from cometary evaporation, then it's not just the skin of the object that evaporated. In fact, it's a substantial portion of the body. And if that were the case, we can figure out what it's made of and definitely conclude in the coming weeks that it's natural. However, it's also possible that the non-gravitational acceleration was produced by thrusters, either a rocket propulsion or some kind of ion thrusters that we use, or some kind of alien technology. And then a few days later, after Perihelion, there were some images taken of 3I Atlas, and they indicated at least 7 jets, tightly collimated jets, coming out of it in different directions, including the direction of the sun.
Right.
And after this image was obtained, there was another one that showed the large-scale structure of those jets, and they extend out to a few million kilometers. Now, as soon as I saw that, I did a calculation. And here you see how far they go. So in the direction of the sun, it's 1 million kilometers. In the opposite direction, it's 3 million kilometers. Now, when a jet propagates in the direction of the sun, it has to overcome the ram pressure of the solar wind. There is momentum flux coming from the sun in the form of the wind. And in order for it to penetrate a distance of 1 million kilometers, that means that it needs to be quite dense because the speed of sublimated volatiles is 400 meters per second or so at the temperature that the surface of 3I Atlas should have had. And the speed of the solar wind is 1,000 times higher. It's 400 kilometers per second. So the jet needs to be 1 million times denser to overcome the resistance. And so I estimated how much mass is carried by those jets. And it turns out it's of order 5 billion tons. And then you say, okay, well, if so much mass was vaporized or sublimated from ice, let's say carbon dioxide ice, which requires the least amount of energy, you need more energy if you consider water ice. But at any event, even for carbon dioxide, there needs to be a surface area that absorbs sunlight that corresponds to an object of at least 20 kilometers. That's much bigger than the diameter inferred for 3I Atlas based on the early image from the Hubble telescope. So what does it mean? It means that if it's a natural comet, then it may have broken up, because then when you make a lot of fragments out of a big object, you get much more surface. So if it's a natural object, we should be able to see the fragments, because they will get separated by the gravitational tide from the sun in the coming weeks. And moreover, a substantial fraction of the mass was vaporized, so we will know for sure that it's a natural comet, and we know the composition and everything. However, if the object maintains its integrity, and we measure the speed of those jets and find that it's much larger than 400 meters per second, let's say somewhere 1 to 2 orders of magnitude is what our thrusters can do, like a rocket or ion thrusters. But alien technologies might have even higher speeds. In that case, the density, the mass of the carried by the jets could be orders of magnitude smaller, and the fuel required to power the jets is a negligible fraction of the total mass of the spacecraft in that case. So just by measuring the properties of the jets, the velocity, the mass content, the composition, we should be easily able to tell whether it's natural or perhaps technological in origin, this object. And that's the fun of doing science, that the answer will come out one way or the other in the coming weeks. And leading to the 19th of December, that's when it will get closest to Earth. And by then, I hope we will know. My hope is really that we will not, I mean, it's 6 days before Christmas, and the hope is it will not deliver any unwanted gifts to Earth for the holidays.
So these images of this, 3 million kilometers in one direction. I mean, some people, you sort of go online, obviously there's constant speculation. One's having to kind of sift through not only kind of quite crazy sort of speculation, but also a complete misunderstanding I've noticed of some of the headlines that or articles that you've been publishing.
Well,
so for example,
to get the correct version, you just need to go to my essays on medium.com, where I work out the numbers. You can just follow them, and you might disagree about a factor of 2 here and there, but I give you the gist of the argument that how do I derive the amount of mass in the jets and so forth.
So do you what in terms of, so there was the potential acceleration, could it have been outgassing? There's these incredibly long tail and anti-tail. Could this be a sign of it basically falling apart? Yeah. Could it have exploded? Does it look like, from where you're standing now, that it's exploded and it's falling apart?
No, it doesn't. Well, the thing is, we see this glow, a very bright ball in the middle, a halo, I should say, in the middle of the image. And these images were taken by relatively modest-sized telescopes that amateurs operate. I am really waiting now for much higher resolution images from the big telescopes on Earth. They were not able to observe it because until today, it was separated from the sun by less than 30 degrees. That's during the month of October, and until now, it was too close to the sun. Even at the sunsets or sunrises, you can't really observe it because it's too close to the telescope will burn. You can't observe the sun. So now it's getting out of the dangerous region near the sun, and there are hundreds of telescopes around the globe that will observe it starting this week, and I very much look forward to that data. But what we see in the images that were released in the past few days is a central glow, and there is no evidence in that for any fragmentation, but it's possible the fragmentation is on scale smaller than the glow, so you can't really separate the fragments. Eventually, as we wait more, like several weeks from now, it's not just the ability of bigger telescopes to give us a crisper image. It's also the fact that the fragments will get separated by gravity, because each of them will feel a slightly different gravitational force from the sun. And the tidal force, which is the difference in gravitational forces between the fragments, will make them separate from each other. And there has been a very nice illustration of that in the fragments of the comet Shoemaker-Levy 9 that was broken up by Jupiter, and it's a series of fragments that we could see on a line, like beams on a pod. And the question is, what will happen in this case? Time will tell.
Yeah, because I mean, it strikes me that most of the images you see of breakup of other comets, such as the one you mentioned, you do see a sort of great sort of spread of debris. This has both had really what look like, some are speculating potentially, as you've suggested, could be, not saying it is, jets, propulsion potentially. Could it be a maneuverability? That moment where there were sort of anti-tails and a tail. Also the 3 million kilometer, that 3 million kilometer tail, that developed very quickly, though, did it not? From the images prior.
Well, we haven't seen it before, and in fact, the plume of gas around Fragmentation was inferred to be of all the 500,000 kilometers by the high-rise, by the Sphere X images back in August. But one needs to remember that as the object, even if it's a natural object, as it gets closer to the sun, it should get warmed up much more. And as a result, the activity may have happened only close to the sun. Now, that period of time when it was closest to the sun, it was of order a month. If you ask how long does it take, at the speed of Sawalha-Adderleys, how long does it cross a distance comparable to the perihelion distance that it was from the sun? And it's of order a month. And with the characteristic outflow speed that you expect for a natural comet, then that's actually the period required to cross 1 million kilometers. 3 million kilometers require 3 months. That's a little long, because 3 months ago, there wasn't any evidence for that.
No.
So you are bringing up a good point that when we see the long jet, the required duration of that activity has to be 3 months at the typical speed of jets from the sublimation of volatiles on comet. And there wasn't enough time, because we haven't seen it 3 months ago. Now we see it. That's a very good point, actually.
Yeah, I mean, so that's my first thought. Every time I look at the image, I think, well, where's that just suddenly appeared from? However long and however intense.
It could appear suddenly, as long as the speed by which the outflow is going is high enough, right? So what I'm saying is that the speed that we expect for cometary, outgassing, at that speed, it would take 3 months to reach that distance. If the speed is 3 times higher, then it would take only a month. But 3 times higher is completely untenable, because when I said the 400 meters per second, it's the highest speed that you can imagine, just for molecules, the thermal speed, the sound speed. If there are dust particles or fragments of ice that leave the object, that they actually move at lower speeds than that. So it would be difficult to imagine a speed as high as 1.2 kilometers per second needed to explain the distance traveled by the long jet over 1 month.
Yeah. I mean, can I ask a couple of questions? Do we have any data yet that suggests it's changed its course? Is it coming any closer to Earth? Is it going any? I mean,
it did. We do have data that indicates non-gravitational acceleration, that it changed its course, definitely, but not by much. And therefore, over a period of a month, it deviated from the expected path by roughly 10 times the size of the Earth. Okay, so that's not much, given the Earth-Sun separation. It's a small fraction. And therefore, there is no evidence that it's maneuvering towards Earth in any way. If it's technological, there is always the possibility that it's a mothership and it released some other probes that are making their way to Earth. There was
Well,
also, sorry?
I was going to say that was one of my slightly, I think, frantic kind of short messages, because I know you're snowed under, where I said, what about this Borisov, this
Yes,
partially interstellar object?
right.
Is this related to it?
Well, that's interesting, because it has a very different trajectory. So they are almost perpendicular to each other. The orbital plane of 3 Atlas is nearly the orbital plane of the Earth around the Sun, within 5 degrees. And the newly discovered object, which was found on November 2nd by Gennady Borisov, the same guy that discovered the second interstellar object, Borisov. So he found this new object, which is moving at 110 degrees inclination. So it's about perpendicular to the plane of 3 Atlas, and it's barely bound to the Sun. So it could be just barely unbound, or it could come from the outskirts of the solar system, the Oort cloud. Most likely, it's just barely. It's still bound, not interstellar, but barely. And the question is it related to 3 Atlas? The two trajectories just dictated by gravity, they don't come closer than of the order of 50 to 100 million kilometers. 50 million kilometers is the separation between the two orbits, the minimum separation between the two orbits, but the two objects never come closer than 100 million kilometers in reality, because they move along these orbits. And so the one possibility is, if this new object is actually maneuvering, then of course all bets are off, because it could have started from 3 Atlas and then went into the new orbit, and that is always possible. That is always possible. You never know. There is just this coincidence that a barely bound object, nearly interstellar object, was discovered around the time of perihelion, the closest approach to the Sun, of 3 Atlas. It's a surprising fact. We don't see these objects very frequently, but it may be a coincidence.
So, Locke, the shutdown of the American government appears to be coming to an end. So, obviously, I don't think you have employed Kim Kardashian yet, or have needed to. But any sign of the high-rise photos, do you think, coming from that?
Not yet.
No.
My guess is that it will take a few days after the shutdown is over, but they will release it. What I was disappointed by is that the bureaucracy overruled science, because the data exists on a computer, and all you need to do is just share it in a common website with the scientific community. You don't need to make a press release. It's not a matter for the NASA headquarters to decide. In fact, the HiRISE team released a lot of images during the past month, except they were saying on their website that they're not allowed to release anything to do with 3A Atlas without approval from headquarters, which is not possible under the shutdown. And the question is, why do they need bureaucratic approval for anything to do with 3I Atlas? Why can they release images of Mars without a problem? Now, many of the people involved are not government employees. They are at the University of Arizona. So my frustration was really about those scientists that could easily share the data with other scientists. And then once the government shutdown is over, they can actually make a press conference about it, release, but they didn't. And someone high up in the administration of NASA decided not to allow them to do that. And the question is why? Because, it's just inappropriate for bureaucracy to suppress the dissemination of scientific knowledge, scientific information. Because if we knew more about 3I Atlas in the past month, we could have analyzed those images. We could have deduced new insights that could help us design our future observations. So science is built on what we know. And if bureaucracy suppresses what we know, that's a pretty bad way to advance, especially in a time-sensitive situation like this one.
I was going to say, I mean, the only possible consequence of an organization like NASA holding on to those images, and, you know, it's really easy to get drawn into the potential, as we've said before, high speculation. I think we've talked in our last conversation a couple of weeks ago about how there's a sort of dogmatic scientific establishment, if you like, that has a vested interest in not entertaining any other thought other than just the strict thought that this is a dead comet. And the anomalies are all explainable by this, that, and the other. But actually, you start to stack the anomalies, and it all becomes, it's like one enormous anomaly.
Yeah, and by the way, they don't explain the anomalies. You have the way to think about these experts or commentators, I should say, people who do not even practice science. Some of them are well-known popularizers of science. The way to think about them is they are just like AI systems that are trained on some data set, and the data set they know about is comets, and so anything in the sky will always be a comet. You know, even if it's a spacecraft and it has non-gravitational acceleration without any cometary tail, they will call it a dark comet, as they did for Oumuamua, the first interstellar object. So I
just can't help but feel that them holding on to if they had nothing, if there was nothing dubious or anomalous within the images themselves, there would be absolutely no issue with being able to show them. And it strikes me that today, albeit that they're from amateur telescopes and various imagery that I've seen sort of knocking about, some of which you have to sort of treat with caution, it's, I don't know about you, but it strikes me that there's a dot going at quite a lick and in quite a sort of non-breaking up fashion. It doesn't, you know, it is what we're looking for in this sort of next 10 days.
That's my impression. That's my impression as well, that it didn't break up when you look at the image. However, it's difficult to explain the mass outflow from these jets, in the context of a natural comet. So once again, we just have to be patient for a few more weeks, and hopefully by the holidays we will know what the nature of this object is.
And finally, I think one of your headlines, because you were in one of your papers speculating that it would have needed to have lost 15%, 16% of its body mass in order for if it was to have been a natural comet. A lot of the papers and news flow certainly over here in the UK has interpreted that as it has lost 15%. We at this current stage, we don't know that.
No, we don't know that. That's just momentum conservation, assuming that the speed of the material that is expelled from the object is that of volatiles that are sublimated by sunlight. And if you were to have thrusters, technological thrusters, that speed will be higher. Then you can actually reach the same non-gravitational acceleration with much less mass. Right. And by orders of magnitude, so just the technologies that we possess would imply at least 1 to 2 orders of magnitude reduction in the amount of mass. So then you get below a percent level of how much fuel you need to burn to get this non-gravitational acceleration. If you imagine alien technologies that have even higher speed for the exhaust gas, you might have a completely negligible amount of mass being ejected, because what matters is the speed times the mass. That's what gives it a kick, to the object. So as you increase the speed, you reduce the mass.
Right. So presumably the other sort of statistic we'll be looking at in the coming days is whether it's moving any faster or whether it's actually, beating predicted dates.
Yeah. So that's why science is fun, because we just need to observe the object. The problem is a lot of people want to tell us stories that because they're showing off. They want to say they know the answer in advance. And not only that this is arrogant and inappropriate in the context of science, where we should be humble and just learn from the data, the evidence, but also it goes against the desire of the public to learn more about it. Because then when you tell the public, you should stay bored, okay? You shouldn't get excited about science. Like, these are the commentators that are claiming that popularizing science to attract the public to science, yet they are arguing the public should not get excited. About this.
I even saw Brian Cox a couple of days ago somewhere in the UK saying, but we don't want people to panic. And it's like, well, can we be the owners of our own panic or our own kind of, in the sense of... One final question.
Just imagine a doctor where you go for an exam and the doctor doesn't want you to panic, so that doesn't tell you that you have cancer. Like, is that a good practice? That's not a good practice. We want to know the facts. We want to know reality. And he will not, Brian Cox will not be the gatekeeper that will suppress the flow of information, or try to argue that he knows the answer in advance, because that's anti-scientific. The science, the scientific method is founded, the foundation of it is the humility to learn from evidence. And yet he claims that he knows the answer without the evidence.
Okay, final question, which I would love you to answer. The reports of the Meerkat radio signal,
right?
Some are sort of suggesting, you know, it's being reported again in such a misinformation-y sort of way.
It is by the way, I was the first one to report about it in my Medium essay, and then the reporters took it from there. Now, this was the first radio signal associated with 3 Atlas. The only reason I brought it up is because it means that these radio observers are now watching 3 Atlas. And I advocated for that for months. I was telling them, because the WOW signal came from the same direction, you should observe. They told me they're doing it. So they observed at the frequency not very far from the frequency of the WOW signal from 1977. They observed some absorption lines, two of them, of hydroxyl radicals, which are basically molecules of oxygen and hydrogen. And you know, those are usually associated with anything that carries some water, but we don't know how much material is associated with the absorption lines. So it could be just a natural, fingerprint of what is around the object. But it doesn't tell us anything about its nature.
I was going to say, because I think it's being interpreted or being used in some of the dogmatic approaches to this as evidence that this is what we get from every comet, some kind of, you know, essential signal, which isn't. I think people are interpreting it as a radio signal, someone pressing.
Well, I would say it's not more informative than finding carbon dioxide or finding carbon monoxide or finding water. These are things that were found by the Webb telescope back on August 6th. So we already know that there are molecules that are familiar to us. We just, you know, don't know what the object is. And, you know, if there is some means of propulsion, who knows, what engine is being employed by this object, and therefore what kind of products you get out of that engine. So the fact that we have familiar molecules around the object doesn't really explain the nature of unless, you know, the object disintegrated, so we are seeing into the body of the object. It's not just the skin, because many of these ices could have been collected along the journey of any object through interstellar space. From the environment, you can collect materials as on the skin, on the surface of the object. And until October, we just saw evaporation of the skin. It was a very thin layer that was evaporated. Now we have a chance, when it came close to the sun, to see the inside of it, in case it's a natural object. However, if it maintains integrity and we see these jets propagating at very high speed, I would argue that's a strong technological signature.
And so just short term now, as we wrap up, over the next couple of days, the next couple of weeks, presumably things like the high-rise images will tell us a lot. Its continued trajectory will tell us a lot. If we see debris, if we continue to see the jets or not. I seem to have, I've got this image at the moment of a ball, a very bright ball, just hurtling through space.
What's surprising is that the jets go in all directions. It's not just away from the sun, the way comets look. There are jets going towards the sun, and we knew it from the start that there was this glow in the direction of the sun, and perhaps that's what the high-res images will show, because for the first time the high-res images would look at the object sideways. When it was approaching us, we were roughly in the same direction as the sun was, only 10 degrees away in the Hubble image, when the Hubble image was taken on July 21st. But high-rise looked at it on the side because it was moving towards the sun near Mars. And so that's what, in addition to the high resolution of that image, the value of it is looking at it from a different perspective at the object and seeing what the outflow of gas or the glow around it looks like.
Well, Avi, thank you so much for taking the time to talk to us again. Thank you for the update, and we look forward to what we find out over the next couple of weeks. My God.
Yeah, stay curious, and the science is fun. Let's figure it out. It's a detective story.
It really is. Thank you so much. You take care.
Thank you.
Bye. There you go, guys. That was brilliant. Some more fascinating context, analysis, wonder, So we really are, in the next, I think, 5 to 10 days, going to find out whether this thing is falling apart or whether it's just this ball that at the moment seems to just be plowing on through space. Thanks for all of your time, and keep your comments coming in, and we'll keep you across this as it develops.